Okay, welcome to EC 540 Control Systems course. So this course is actually a continuation of Signals and Systems course. So in Signals and Systems, you have studied continuous time signals, continuous time systems, discrete time signals, and discrete time systems. So you have studied what is a signal, how do you represent a signal in time domain, how do you represent a signal in the frequency domain, how do you represent a system in continuous time domain and in the discrete time domain. So as a continuation of that course, so Signals and Systems is a foundation course for the EC department. So most of your other courses depend on the knowledge that you gain in the Signals and Systems course. So for example, this semester, you will be studying control systems as a application of continuous time signals and systems. And you'll also be studying digital signal processing as an application of discrete time signals and systems. Okay, so it is very important that you review that subject, signals and systems. Okay, so let me begin by getting to know familiarity with the concept of if you are already familiar with control systems. What do you mean by control systems? I would like to know what idea is there in your mind regarding control systems. So can you give me some examples of control systems? Examples of control systems in your day-to-day life. Any examples? Air conditioner, thermostat, dishwasher, automobile. Okay. Okay. So you already, at least some of you know what are the applications of control systems. So I would like you to so all the course information. So this is a 310 course in reality. So 3 lecture hours, and you have supposed to have one tutorial during the regular semester. Okay, but So maybe the tutorials will be covered separately once the offline classes will begin. So this is my, so there is separate course web page. So all of you can see the course web page. Okay. So these are the course outcomes. So course outcomes is, first you should be able to represent a physical system as a mathematical model, right? So in signals and systems, you know how to write transfer function, right? And you have done some transfer function for the networks, RLC circuits or op-amp circuits you might have done. So the same concept has to be now extended to some mechanical systems, electrical systems, and electromechanical system. Okay. So that is the first course outcome. Then we will do some time domain analysis and frequency domain analysis, and then we have to design the controllers and then implement. So first, representation of the physical system, so that is modeling, mathematical modeling. The second part is analysis. Okay, so analysis in time domain and analysis in frequency domain. Then the third part is design. You'll have to design the controllers. And the fourth part and the final part is implementation. And you have to validate and test your design. So whatever related tools and techniques we will study in this class. Okay. So first of all, we need to know what do we mean by controlling. Okay. So this is the syllabus. You can go through the syllabus, and these are the textbooks. Okay, so the link is given here to the Amazon. You can buy from any other website also. Actually, this is not the Indian edition. The Indian edition is also available. just do some research, you'll get it. Also, library has copies. And this one is definitely Indian edition. Control Systems Principle and Design by M. Gopal. Okay, and then there are other books, Norman Knights and Ogata. So these are the textbooks. So CIE pattern is there will be 5 events, 3 tests, and 2 long-term events. So the long-term events, for that we use some computation tool. You can use MATLAB, Python, or Octave. So you need to be comfortable with these tools, MATLAB, Octave. So if you are not familiar, you need to get familiar, write some basic programs. Okay, then I will also discuss in the class the functions that will be used for the control systems. But you should be knowing the basics. Okay. So it's your responsibility to go through whatever is done in everyday class. The class lecture will be, the slides will be uploaded for each class. Okay, so it will be either PPT or the notes will be uploaded. So it is your responsibility to go through it regularly. Even the course website will be regularly updated with new information. I may post a video, I may post some interesting web link. So it is your responsibility to constantly be in touch with this course website. So a lot of content is already there, so you can go through it. So I'm just posting this. Some content is old, but it will be updated shortly. So I'm giving the link in the chat box. So before we go into technical details, I want you to introduce with some history of control systems. Just a second, I'll just come. So it is very interesting to know the history of control systems. Like so the basic idea of a control system is you have the some process that you want to control or some machine that you control. When you are controlling some machine, the machine has some variables, right? So if you take aeroplane, the aeroplane controlling the aeroplane means controlling the its various variables, like what is the altitude from the ground, what is the pitch angle or yaw angle or whatever those angles it is making in the sky, okay, and with what speed it is traveling. So those are the variables of the associated with the aircraft. So you want to control the aeroplane means you are basically controlling